Good morning, everybody. Now here's a Keb F4, and it is article number 09.F4 S1D-4A01/1.2. Now if y'all can help it, don't work on these. They are hard to get apart. What makes them hard to get apart is that underneath this plastic housing is a three-phase bridge and the IGBTs, and they're soldered to the power board right here. This sits in here like this, and you can see that you have to unsolder those IGBTs and three-phase bridge before you can get this out for repair. This drive had leaky capacitors. They were leaky and low in value, so it needed to come apart and get recapped. The IGBTs and three-phase bridge are good, so we're about ready to put this thing back together. But before I go to work on that, I've got to work on this right here. This come out of a air handling system, Weather-Rite, part number 11025101. We have to see what's going on with this before we can work on that. Around here the work never ends. Okay, we'll get back to that drive in a little bit. First things first. Evening all. Here we are looking at the power supply circuit of the Weather-Rite air handling system. Now if you'd ever been in a factory where the temperature gets a little bit too hot in the summertime or too cold in the wintertime, you can know how insufferable it can be. This little board right here is part of the air handling system of a factory, and so we had to get it up and going pretty quick, otherwise them folks out there would be not enjoying their lives while they was at work. Now what I found bad was this 7824, it's L7824CV 3-terminal regulator, had a hole in it. And this filter capacitor right here wasn't doing its job. It was down in the picofarad. When I put it on the seg cord, measured 3 picofarad, so it couldn't regulate anymore. It couldn't filter anymore. The bridge rectifier was good. These two fuses right here, a T 800 milliamp 250 volt MST fuses, they had opened up when all of this circuitry right here gave up the ghost. Everything else was fine. We got an LM317LZ. That was okay. The Zener down here, this was okay. The bridge rectifier was okay. Just these two components right here failed, and they took out the fuses. When I replaced those, I was able to test the board. Now, I always like to try and fully test, if I can, and I can't all the time. I always like to try to test my repair. Now, in this situation right here, all I would have had to do was apply a voltage to the bridge rectifier and look at the 24 volts DC out here and the output of the LM317LZ to make sure everything was okay. But I always go a little bit farther than that. I want to understand what I just worked on. And so we're going to take a peek at the circuitry. Now this right here, down here, is the plus V out and minus V out connector. that connects this board's output to the circuitry of the air handling system. Now this point right here, plus V out, is tied to a series resistance relay network, and that varies the voltage that we see out here on plus V out, minus V out, depending on which relay is energized. Now the folks that designed this circuitry, that's pretty smart. I'd never thought of doing this. Let's go look at it. Now here is the point that was connected to the plus V out connector, and that Zener diode and LM317LZ right here. It is connected to K1 common, and then we have a resistor up here, a potentiometer up here that we can adjust. We're connected to K2 common and another potentiometer. This is R1, R2, K3, R3, K4, R3, and then R5. Now R5 is always in the circuit, but depending on which relay input is energized, K1, K2, K3, or K4, potentiometers R1, R2, R3, and R4 are also applied to R5 and the plus V out. So, if I were to energize K1, this contact would close, and plus V out would be applied through R1 to R5. If I were to energize K2, de-energize K1, then R2 would be in the circuit. Isn't that smart? And the same with K3. Energize K3, and now we move through K1, K2, up through K3, and across R5, through R3. Oh man, that is something else. How'd they figure this out? Same with K4. Let's energize K4. Now, plus V out is connected through K1, K2, K3, and up through R4 and across R5. So depending on whether we have K1, K2, K3, K4, any combination within, it applies R1, R2, R3, R4 to R5 back to ground right here. That's amazing. So you can vary the voltage at plus V out dependent upon the resistance to ground right there. And that total resistance determined by whether K1, K2, K3, or K4, or any combination of these relays is energized. That is so amazing. Amazing how people can sit there at their house and think about this. You know what, I'm going to do it this way. Okay, let's look at the next couple of sheets here. This is the brunt of it right here. This is the workhorse part of it. Now when I power up that Weather-Rite board, 24 volts DC is applied to these two pins right here. And I take that 24 volts DC, either terminal, doesn't matter, there's 1, 2 right here. and put it up here on, connected up here on pin 1. The relay turns on, that red LED, and the K1 relay turns on because current flows from plus 24 through the K1 coil back to ground. The same with 2. Put 24 volts up here on pin 2. The red LED turns on and K2 turns on. And down here, we take 24 volts into 3 or 4 and 4, and this LED turns on. K3 energizes because we have 24 volts going through the coil to ground. And here the same on 4. Red LED turns on. K4 energizes because we have current flow from plus 24 through the red LED, through the coil of K4 back to ground. Those are the 4 relays that are in parallel with the 4 potentiometers. Here's the coil of the K5 relay. Now look what they're doing here. We have K1, K2, K3, K4 contacts. These are the second contacts of the K1, K2, K3, and K4. Either one of these, when it is energized, will energize K5. Watch this. We have plus 24 volts DC up here through the coil of K5. When K1 is energized, K5 is connected to ground. When K2 is energized, K5 is connected to ground. K3 connected to ground. K5 is connected to ground. K4 plus 24 up here. And through the normally open contact, which is now closed because we've energized K4, connects K5 to ground. When K5 is energized by closing either K1, K2, K3, or K4, or any combination of which, these contacts right here at H1 and H2 are connected. They are closed together. There you go, folks. That's the entire circuit of that air handling system, PCB, the Weather-Rite air handling system PCB, part number 11025101. They call it the auto cycle control board. And if that ain't working in your factory, you're going to have a bad day. All right. All right. All right, folks. Thanks very much for stopping by and seeing what we're repairing today. We'll see you next time. Let's test the board. I'm going to get on the plus V out and minus V out terminals. And you can see we have 3.662 volts DC with none of the relays energized. Let me pull input 1 up to plus 24 volts DC. Relay 1 is energized, indicated by that LED, and we have 10.84 volts DC at the output. Let's go to input 2. We have 10.77 volts DC at the output. Here's input 3. We have 8.89 volts at the output. And here's input 4. We have 4.87 volts DC at the output. That's good. Those relays are working. Now, let's go to the H1 and H2 terminals. Put our meter in resistor mode. And any of these inputs will energize this K5 relay. We've just energized the K5 relay, and that output has closed. That's good. Good. Closed. Open. Closed. Open. That board's good. That board is good. All right, folks. Thank you very much for stopping by and watching us test that air handling system board. We'll see you next time.